Okay, so the last shortcut we're looking at is called a perfect square trinomial. So we're seeing that squared term show up, but it's going to show up in a little different way this time. I just want to give a few reminders about all the shortcuts from what we did yesterday. Number one, you don't need to memorize these shortcuts. Yes, it is helpful. Okay, if you actually spend the time to learning these shortcuts, it can save you some time anytime that you're actually needing to factor something. Always look for GCFs. Sometimes that's the only thing we need to do. And then remember just to check our work. Okay, so even after we go through these, if you're like, I don't understand that, it is okay. Okay, but ideally we can pick up on some of these, especially like the main one from yesterday was factoring when A is 1. Those are ones that I'd say we should catch on to. Okay, that saves us a heck of a lot of time when we know that A is 1. All right, so then the other shortcut we looked at are the perfect or difference of squares. That one's helpful. Again, you don't need to have that one memorized, but if you recognize that one, really quick to use that formula there. All right, so the last one, the perfect square trinomial, and kind of similar to the difference of squares, it requires quite a bit of recognition. So here's how we know we have a perfect square trinomial. We have a squared, or for us with a quadratic, it'd be like a squared x squared. So the a value is still a perfect square. Okay, and that's what this is saying is square of the first term of the binomial. Binomial being our factored expression. And then it would be plus 2abx and then plus b squared. Okay, and that b is kind of like our c term, that constant term. And so basically we're looking for is our a value a perfect square? Is the c value a perfect square? And then is the coefficient in front of x, those two square root values, is it 2 times that a times b? And so let's do, again, just a couple recognitions. And remember, we don't need to have this memorized. In fact, let's start with just factoring this in general. Okay, so if I saw this quadratic, even me, like I don't know that I would recognize right off the bat that this is a perfect square trinomial and would use a shortcut. Instead, I would go, okay, what two numbers add to b2 and multiply to 1? Well, that would be 1 and 1. And so when these numbers end up being the same, that's kind of how we know, or another place to kind of catch on to this factoring shortcut. So then this means since a is 1, our factors are x plus 1 times x plus 1. And so a lot of times you'll see this written as x plus 1 squared, right? Anything times itself is just that thing squared. Okay, so even there, I don't know that you need to recognize the perfect square trinomial. Just factoring it in general can go a little bit or fairly quick. So the second one, let's see if we can't use the actual shortcut and recognize how we could just bypass finding the two numbers that adds to be and multiplied to a times c. So a equals 1 here, and the square root of 1 is 1. It's a perfect square. 16 is c. I know in the formula they use b, but we can think about it as c. That'd be 16, and the square root of 16 is 4. And then 8 is equal to 2 times our a value times our c value. Right? A is 1, c is 4. 2 times 1 is 2, times 4 is 8. So I'm like, oh, I have that formula. But you can already see how much recognition it takes, right? We have to go perfect square, and then 2 times each of the square root values of our a and c. So if that's the case, this is going to factor to a plus b squared. And that's one thing that I didn't quite mention before in that formula. Again, the b is essentially our c value in this case. So this would be x and then minus 4, x minus 4 squared. Not that squared. X minus 4 squared. Okay, again, if you're looking at this, you're like, I have no idea where anything is coming from, factor it the long way. Okay. In fact, now that I'm actually going through this, I don't know that it helps all that much. let's see. Let's do like these last two and see if we can't see if the shortcut really helps us. So let's pretend that we don't recognize this at first, and so we decide we're going to find two values that add to b, add to -8, multiply to a times c. That'd be 16. Those numbers are -4 and -4. And so again, when those numbers end up being the same, that's what kind of tells us that we have a shortcut, right? That's going to be this perfect square trinomial. Now, be careful here because a is not 1. So my factor is not x minus 4 times x minus 4. Remember, these two numbers, what they're doing 100% of the time is they are taking the -8x and splitting it up into those two terms. So -4x, -4x. So now I've got 16x squared, -4x, -4x, and 1. And one thing that can kind of help us when we're actually factoring here with this is since these numbers are the same, our factors should be the same. And so when I go to find my outsides and looking at greatest common factors, it's going to be a 4x and a 4x. Okay, that is the greatest common factor of this given row. 4x is the greatest common factor of this column. And then 4x times -1 is -4x. 4x times -1 again is -4x. And -1 times -1 is 1. So this factor is 2, 4x minus 1 times 4x minus 1, or 4x minus 1 squared. Okay, so that was, I kind of used the fact that it was a shortcut just to help me figure out what the outsides needed to be. But right, I'm not using that actual formula here. Let's see if we can't bypass the box and actually using one of our formal factoring methods for this last one. And for the last one, I'm immediately recognizing that I have an x cubed, an x squared, and an x. So we have a greatest common factor where we absolutely need to factor out an x. But then I'm also noticing all those numbers are even. So another common factor would be 2. I'm wondering if there's another greatest common factor there. I think it's just 2. Because 9 doesn't divide anything else. 4 doesn't divide 18. Yeah, so it's just 2. So we're going to take out that 2x. Again, the 2 isn't necessary. The x is necessary. X absolutely has to come out of this. So 9x squared, that'd be plus 24x, and then plus 16. So I'm like, hey, I recognize that 9 is a perfect square. Square root of 9 is 3. I recognize that 16 is a perfect square. Square root of 16 is 4. So for this formula to work, we just need this b value, 24, to be equal to 2 times a times c. So 2 times 3 times 4, that's 6 times 4 is 24. That's exactly what we had. So I'm like, hey, this fits that perfect square trinomial formula where this is going to factor to the perfect square, so 3x, and then all these are positive, so 3x plus 4, 3x plus 4. So this 3 is that 3x, this 4 is that 4.